first lesson is 4.5, graphing using slope-intercept form. You should be on page 244. Now, I want to talk about the title real quickly, Slope-Intercept Form. I'm going to underline those words, Slope-Intercept Form. The reason we call the equation that you're going to see in a minute, slope-intercept form, is it tells you the slope and it tells you the y-intercept by just looking at the equation. So this is a great form to use. It allows you to graph without even making a table or without even using your calculator. So I should put a little note here. A lot of these things a lot of the quiz and questions over this, I would make no calculator on a quiz or test, okay? So let's look at what slope-intercept form looks like, and it's right here. Let's show you how we find the slope and y-intercept of a line using this form. Now, first of all, here's what the form looks like. Y equals mx plus b. Now, the letter M, remember, stands for slope. So whatever number I see there for M, that would be the slope of my line. And the value for b is called the y-intercept. And you know the y-intercept, it's where a line crosses the y-axis. Here would be an example in this box right here. I'm going to circle it. Here's slope-intercept form. Do you notice in this equation, the slope of this equation would have to be 1/3 because that's the value that is represented by m. So this equation has a slope of 1/3. Now, the y-intercept is b. The slope of this, the y-intercept, I meant to say, of this equation would be 1. Now, it ought to be really easy for me to graph this then. My y-intercept's 1, so I'll put a point here at 0, 1. You can see they did that. And now my slope is 1/3. Now, think about 1/3. 1/3 means we're rising 1. I'm going to write these in. We're going to rise 1 and run 3. So from my y-intercept, I can go up 1 over 3 and put another point. And now from this point, I can go up 1 over 3 and put another point. And you see, if I take my ruler out and draw a line, I'll have the line that the book had. I didn't need a table. I didn't need a calculator. I can now graph a line by just looking at the equation. But here's the thing. This is the key thing. The equation has to be in y equals mx plus b form, which is called slope-intercept form. You have to have the equation in that form before you can actually determine the slope and y-intercept. Let's try a few. Let's identify the slope and y-intercept of each of these lines. So let's look at number 1. It's y equals 5x minus 3. Now, here's the first question. Is this problem in that form? And the answer is, well, yes, it is. It's y equals mx. When it says plus, it could be plus or minus b. Well, mx minus b. Well, can you see how m, let me get a highlighter. I'll use the same colors I did up here. M is my slope. My slope has to be a 5 in this problem. My y-intercept, it has to be a -3. So if this was a problem on a quiz and I asked you to identify the slope and y-intercept, I would write m equals 5, there's my slope, and I would write b equals -3 for my y-intercept. Let's look at this one. I want to find the slope and y-intercept. So here's the first question. Is this problem in that form? I hope you're noticing, wait a minute, that's not slope-intercept form. I'm going to put, this is standard form. Well, I can't get slope and y-intercept out of standard form. I have to rewrite this in that form. Okay, well, here we go again. You got to be able to solve for y correctly. So let's solve for y. So I'm going to onion. I want to onion the y. I want to solve for y. So I'm going to take away the 3x first from both sides. So that would give me -3y equals 12 minus 3x. And then I'm going to have to divide each side by negative 3. And I'm going to break this over here up into separate fractions. So I'm going to have 12 over negative 3. Oop, that's a positive 12. 12 over negative 3 minus 3x over negative 3. Okay, positive over negative is a negative, so I'm going to write my answer up here. So y would equal, I have 12 over negative 3, which is negative 4. Negative over negative is a positive, and 3x divided by 3 is 1. And let me just rearrange this so it looks nicer. I have 1x minus 4. Okay, now that's in slope-intercept form. Okay, well, what's my slope? Well, I can see it now. M has to be a 1. So I'm going to highlight that here, and M is 1. Oops, but I want that to be an orange. Let me, my pen isn't responding great here. Let me get that first. Okay, so M is 1. That's my slope. And can you see I highlighted my y-intercept in blue? My y-intercept is negative 4 for this problem. Okay? I'll let you try number 3 on your own, but you notice this is also in standard form. You should solve this for y, and then you can get your slope and y-intercept from that. Okay, now, next, let's talk about, let's now graph one of these. I want to graph the equation y equals negative 2x plus 5. Do you notice that this is in slope-intercept form? Okay, so let's highlight. My slope is right here in front of x. It's negative 2. That's my m value. So now remember, that would mean negative 2 is the same thing as negative 2 over 1. So a slope of negative 2 means I'm rising negative 2. Now a rise of negative 2 means I'm really falling. I'm falling 2, and I'm running 1. Remember, rise over run. And then here's the next thing. Can you see how my y-intercept is 5? So B is 5. So let's keep those two in mind as I go to my graph paper now. Okay, I'm going to go to graph paper. My slope is negative 2, and my y-intercept's 5. So I don't need a calculator. Go to 5. That's my y-intercept. My y-intercept's 5. We said B was 5. And then we said our slope was negative 2, which is the same as negative 2 over 1. So this means drop 2. So remember, this is the rise. Drop 2, and then run 1. So let's do that. Drop 2, run 1, put a point. Drop 2, run 1, put a point. I'll do that a few times, and now I can take my ruler out and draw a line, and here is the line for this particular equation. It's this right here. Don't forget to put arrows at the end. You notice how I was able to graph that, and I did not need a table, and I did not need a calculator. So that's why when I have you, or I quiz you, when I quiz you on slope-intercept form, I really can't let you use the calculator, because if I do, it doesn't mean that you know anything about the form. I got to actually quiz you on this without. Okay, now, in real-world problems that can be modeled by linear equations, the y-intercept is often the initial value of the problem. So whatever number is in for B in the equation, that's often the initial value of the problem. The slope is the rate of change. We talked about rate of change in the last problem, or in the last video I meant to say. We are comparing two quantities in a rate of change. All right? So when we look at this sample problem, it says to get from one floor to another at a library, you can take either the stairs or the escalator. If you climb the stairs at a rate of 1.75 feet per second, and the escalator rises at a rate of 2 feet per second, you have to travel at a vertical distance of 28 feet. The equations model the vertical distance you have left to travel after t seconds. So if I take the stairs, every time I climb stairs, I'm cutting down my distance 1.5 feet per second, but I got to get to 28 feet. That's where this equation comes from. Can you see how that is in slope-intercept form? Okay, now they use d instead of y, and they use t instead of x, but let me highlight. Can you see how the slope, or the rate of change, is here? We are cutting 1.75 feet per second off of our climb if we are going up the stairs, is what this is saying. On the escalator, however, you can see the slope is -2. We are cutting 2 feet per second of time by using the escalator as we're trying to get up to 28 feet. And then, can you see the initial value? Here's my y-intercept. Okay, so when we start on the escalator on the stairs, we have 28 feet to go, and every time we travel a second on the stairs, we have 1.75 less feet to go. On the escalator, 2 feet less to go. You can see the escalator is traveling faster. All right. Well, I could graph both of these, which you see here, and I could answer questions based on my graph. Okay. Let's talk about parallel lines, and this definitely want to get this in our notes. Two lines in the same plane are parallel if they do not intersect. That means if they do not touch. So if you have two lines on a sheet of paper, if they do not intersect, they must be parallel. Now, that's important, but the next statement is even more important for our arithmetic. So this is something we definitely want to get down. Okay, slope gives the rate of change, or the rate that a line rises or falls. So if two non-vertical lines with the same slope are parallel, so if I use my slope calculation, remember, to calculate the slope, we would use this formula. This is the slope formula. That formula, if we use that formula, if I find two lines that have the same slope, in other words, if I do this formula for two different lines, if I find out that the slopes are equal, that means the lines have to be parallel. So you'll see that example here. Here's an example problem. The book will have you definitely do questions like this in the homework. They will give you three lines, and they'll ask you to determine which are parallel. Now, here's what you can't do. You can't say, well, it looks like the first and third aren't going to touch, so they're parallel. No, they're asking you to find the slope of each line. And when I give you a quiz or test, I would make you do that. I would say, calculate the slope and show me if the lines are parallel. So you notice for line A, which I'll highlight in blue, they took these 2 points, and they are calculating the slope. They took -1 for y, -0 for y, and they took -1 for x, -2 for x, and they found the slope was 1/3 for the blue line. Line B, or I'm sorry, line A in blue. Line B, I'm going to have green. So you can see they calculated the slope. They did -3 for y, -1 for y on top, and they took 0 -5 on the bottom, and they got 2/5 for the slope. Is it clear that these two lines are not parallel? They don't have the same slope. Let's now go to line C. So for line C, which is, I'll put purple, here are the 2 points. They took -5 -3 for the y's. They took -2 -4 for the x's, and they calculated this out and got 1/3. Is it clear that line A and line C have to be parallel because you notice the slopes were both the same? That's when you do the homework questions over this today, when they're asking are the lines parallel, that's what I need you to do. I need you to calculate the slopes. Okay? I'm going to pause the video here. If you have any questions, make sure you ask in class.